one of the major support systems are pillars in the mine, where we try to leave some of the ore as pillars or low-grade material as pillars, or we bring in artificial substances as pillars. So we are saying in pillar mining, pillars of coal are used. Most of these principles were proposed by the Americans, and most of these places, they work on coal and not gold mining. And so you realize that most of these pillars and other stuff materials you come across always use the coal. That does not mean that systems have been tried and tested that it can be used in hard rock mining. And so you shouldn't fear when you meet some of these materials and you see coal, meanwhile you are in a gold mine. So coal are used as basic support. So usually low-grade parts of the deposit, as earlier stated, are used. Then systematic arrangement of uniformly sized size of pillars are feasible and desirable. So you have to use uniform sizes of the pillars. That can help you do your calculations with ease, rather than randomly deciding sizes of pillars over there. So we try to use uniform sized pillars for our calculations, for ease of calculation. But situations where it is difficult to do that, you go about with the irregular ones. So pillars may be of any form and shape, okay, any shape and size rather. So in terms of shape, they may be circular, they may be square or rectangle. And if it is possible for you to bring about a triangular pillar, and you know how to go about your computation, so we'll get to a section where we'll do calculations on the pillars, and you will now understand why it is good to go with squares or maybe rectangle rather than going with triangles. When you get to the numerical analysis, you get a better understanding of that. Then pillars are splayed at top and bottom to increase area of support of floor and roof, or floor and then the roof. So you bring in the pillar, erect it, as in the case of this, it provides support at the base and support at the top. Then we have in pillar mining in general, heavy roof requires longer pillars and smaller openings. So if you have materials that are heavy, we prefer that you bring in a pillar that is long. Then the openings where you are going to be working to be smaller. This is the place you are going to be working. So that place should be smaller, and then you have thin, longer pillars. Then we have, this is deposit, sorry. Then failure to recognize roof pressure in working out a room and pillar system may cause squeeze. So as we are going to do computation for the pillar design, if you don't recognize the amount of pressure that is being exerted from the materials that are going to sit on top of that pillar, because when you leave a pillar, it is absorbing. For example, you are putting up a 3-story building. Any pillar there is providing support for the topmost floors. And so if you don't check the amount of pressure that is going to be exerted on the pillar, it will bring about squeezing. Squeezing, and finally, there will be crashing of your pillars, meaning a collapse of whatever structure you have put in place. In the same way, underground, you have to check for these pressures that are going to be exerted on your pillars to ensure their sustenance. So this may occur during test mining and often during robbing where removal of even one pillar may transfer to adjacent pillar weight exceeding their support power. So what we are saying is, if I am going to begin my mining activities, I have to ensure that I have checked these pressures. And remember, we earlier on stated that we are going to use part of the ore we are mining sometimes, or most of the times, is part of the ore we are interested in that we are going to use for the support. And so, man, out of greed and per our calculations we have done, if we finish mining and we think we are finding it difficult to leave those huge pillars full of high grades, what we do is that we go back to reduce the dimensions of the pillar. That is what we call pillar robbing. So I left a pillar this size for support. Then later, after I have finished my activities, I feel like there's so much left there. So I decide that let me rob, that is robbing, stealing part of the pillar for production. And then I leave something like this. But what the note is telling us is that when we do that, we should remember that when we collapse any pillar, the pressure that was carried or borne by this pillar is going to be distributed across to nearby pillars. And those pillars that these stress are going to be transferred to, are they in position to accept that kind of pressure that is coming? That is what the point is talking about. And then gunite has been used to stop slacking and crashing of old pillars. So after I have finished robbing my pillars, or I leave a pillar for some time and I feel like it is getting weaker, there is this thing we call the gunite, where we brace the whole of the pillar with some kind of metal like iron rods all around it, and then we spray some concrete material in it to hold it in place. So it is one of the measures people put in place to avoid crashing of pillars. Then pillars have been enlarged and straightened by building forms around and filling with concrete. So then we have old pillars have been reinforced with tie rods by placing vertical steel rods against. So it's just like where I have a pillar, just like we do with electric poles. Okay, so or when you have a plantain and it's about to fall off, you chalk it up with some kind of steel or wood. So you can undertake some of those activities at old places where you think there's that likelihood of your pillars being weak. Where possible areas of low grades have been utilized for pillars leading to irregularity, then axis of pillars is at right angles to the depth of the deposit. Then what is the state of stresses? So you realize that all throughout this course, it has always been stresses and strain. And that is why I said it is picking in basis from physics, strength of material, and then basic mechanics or mechanics of materials. Okay, so you cannot talk about rock mechanics leaving out your physics and your other mechanical properties of materials. And so what is the state of stresses underground? So the design of an underground structure in rock differs from other types of structural design by the nature of the load operating in the system. So the type of load material it is going to bear makes this different, okay, within the underground. In conventional surface structures, the geometry of the structure and its operating duty defines the load imposed on the subject. The geometry of the structure and its operating duty defines the load imposed on the subject. So if I have a material, normal construction material, and I want to provide the surface structures, okay, I consider just the geometry and then the type of load it is going to. Or sometimes when I provide the structure, it can help me predict how much load it is going. But in our case, it is the reverse. You always need to check the material or the pressure or the stresses that are going to be acting. And that is where you design your stuff to prevent failure. For an underground rock structure, the rock is subject to initial stresses. So the formation is already there. It is carrying stresses already. Unlike normal conventional materials like you coming to put up a building and your roof, you have no stresses up there. You are now coming to put in the truss and whatnot to get the structure for your roofing. And per the material you have put there, you now come and put the stress on top. But in our case, we already have a rock that has got internal stresses. And you have compounded these particular stresses within the rock, and you now want to provide support. So the final post-excavation state of stress in the structure is the resultant of the initial stress and the induced stress. So we have the pre-mining stresses, which are the stresses existing within the rock formation itself. And then when you have caused your disturbances, if you want to compute for stresses this time around, it is that initial stress that existed before your destruction plus that stresses you are going to cause or that is being induced by your activity. So these two things come together to give us the post-excavation stress. So you have excavated. The rock already had internal stresses. You have done excavation, and this comes to add. So you have your final stresses being the initial and your induced. These together will give you the final or the post-excavation stresses. Since induced stresses are directly related to the initial stresses, it is clear that specification and determination of the pre-mining stress is necessary precursor to the design analysis. So since the induced stresses is going to be directly proportional, okay, it's going to be influenced because before you go in there to do that excavation or whatever, you need to first have a fair idea what your pre-stresses are, which will help you go about your design analysis. And then when you are to do the excavation, you predict that if I open the space at this much wide, what will be the resulting stresses that will come to add to these pre-stresses that exist.